Hi, today's notes are on 1.4c. We're going to continue finding trig functions, and today I'm going to be giving you angle measures. So it's important to remember that trig functions are ratios, like sine, cosine, tangent is what I mean by trig functions, which mean they are the same for any triangle with the same angles. Okay, because if you take like a side divided by another side and you have a larger triangle, it's going to reduce to be the same fraction. Therefore, for special right triangles, all 6 trig ratios are the same for the same angles, even if the sides are different. Okay, so let's prove this. Let's see. We're going to find just sine, cosine, tangent. Okay, so let's see. We will have sine theta, cosine theta, and tangent theta. Let's see, this will be for 60 degrees. I should say sine of 60 degrees, sorry. We know that A is half of the hypotenuse, so that'll be 4, and then B will be 4 root 3. Right? So sine will be 4 root 3 over, opposite over hypotenuse over 8, which reduces to root 3 over 2. Okay. Cosine will be adjacent, which is 4 over 8 over hypotenuse, which is 1/2. And tangent will be opposite over adjacent, which will be 4 root 3 over 4. That reduces to just root 3. So far, so good? Okay. And this is assuming it's 60 degrees, which, you know, we do place on the xy axis in quadrant 1. Okay. Let's do another 60-degree special right triangle, right? If it's 60 and 90, the last angle must be 30. So if the hypotenuse is 4 this time, then A is equal to 2, and B is 2 root 3, based on that pattern that we've memorized. So let's do sine theta, cosine theta, and tangent theta. And so we know sine is opposite over hypotenuse, which is 2 root 3 over 4, which is root 3 over 2. Okay. One could be a coincidence, so let's prove it with the second one. Adjacent over hypotenuse for 60 degrees is 2 over 4, which will be 1/2. And then the last one will be tangent theta, which is opposite. This would be 2 root 3 over opposite over adjacent, which is over 2, and that's still root 3. So what you'll see is that for the special right triangles, 30, 60, 90, or 45, 45, 90, or multiples of those angles, the trig ratios are actually set values that do not change ever, regardless of the lengths, which means we can ignore the lengths. Okay, so I'm going to write here, okay, to not know lengths. But this only works for special right triangles. We don't know yet if this matters for others. Okay. So let's find trig ratios given an angle measure of a special right triangle. So given the angle measure, find the exact value of the remaining trig functions of angle theta. Use exact values, not decimals. And I'm going to add in here directions because it will be on your quiz. Sketch the triangle. Okay, so 300. So the thing you need to decide is if this is going to be a 30, 60, 90 triangle or a 45, 45, 90 triangle. My hint to you guys is if it ends in a 0, it's going to be a 30, 60, 90. If it ends in a 5, it's a 45, 45, 90. Okay, so I'm going to start at 0. I'm going to go all the way to 300, which is past 180, past 270 by 30 degrees. Right, so this is 270. So this is 300. So this triangle right here, if it's past 30, then the remainder is 60. Okay. And so now we can put in some length. Sorry, let me draw that triangle a little bit bigger. We do know that this value is a negative number, this one's a positive number, because here is 0, 0, right? And the radius is always positive. So now let's assume that we have these like set values rather than picking like being given values, right? So I think if you remember my mistake from day one, the easiest value is to set the shortest side equal to 1, and then we can figure out the rest of it, right? So double is hypotenuse. I should put this as 60. And then this length will be negative root 3, or 1 root 3. So now I can do sine, cosine, tangent. And this will be, let's see, sine is y over r, cosine is x over r, and tangent is y over x, sorry. Please remember that when you draw your triangle, you want to go from the terminal side of your triangle up or down to the x-axis. Okay, and that's why I'm drawing this triangle here instead of to the side here. So let's take a look. Our y value is negative 3, so it'll be negative root 3. Radius is 2. Let's maybe label these. This will be x, this will be y, and this will be r. Okay, that's set. Can't simplify that further. X is 1, and r is 2. And then y over r is negative root 3 over 2. Oh no, I'm sorry. X is 1. Let's try that again. I was like, something doesn't look right here. Sorry about that. Let's relabel. So y is negative root 3 over 1, which is the same as negative root 3. So is this a coincidence that these numbers are exactly the same as the ones we did here? No, because if you look at it, it's the same triangles, right? So the only difference is that we do need to take into account the positives and negatives. So y is negative, so anything with a y has to have an extra negative show up this time, right? So it's the same values that we did up here. We just need to be careful of our signs. But on a quiz, you need to show this to be sure that your memorized numbers are correct. Cosecant is the inverse, or the reciprocal, I should say. So it's 2 over negative root 3. That'll be 2 root 3 over 3. I'll put the negative on top. Secant theta equals to 2 over 1, which is just 2. And cotangent theta equals to 1 over negative root 3 equals to root 3 over 3. And I'll put the negative on top as well. Okay. So let's keep going. We'll do another one. Let's see. This time we're going negative 225. So I'm going to just do better and draw a bigger x and y axis this time, just to make it more clear. Let's see. Negative means we start at 0 and we go down. This is 90. 180. I know this is 270 and this is 180. This is 180. This is 270. 225 is exactly in the middle, so it's going to be a 45, 45, 90. So this is negative 225. Notice I'm labeling my original angle on here, which you guys should get in the habit of doing. But then I will draw my triangle and put in 45 degrees for my reference angle. So it's a 45, 45, 90 triangle. That means we get to, once again, place our values, and we always make the shorter side. Over here it was 1. Here both sides are 1, right? Because they're the same side. So this will be in the negative direction. I have to confirm that. So that means x equals -1. And going up is +1. So y equals +1. R equals to √2. Okay, if you remember, that's our pattern. X, x, x √2. So now we have everything we need for sine, cosine, and tangent. So we know sine theta equals, and I'm going to keep writing the formulas just to help me remember it, or help you. Y over r is 1 over √2, which is √2/2. This time the x values are negative, so cosine has an x in it over r, which means I have to be careful here and go -1 over √2. So that's -√2/2. Negative goes on top. And then we have tangent theta, which is y over x. So y is 1 and x is -1, which gives us -1 as a final answer. We'll keep going. Cosecant theta is the reciprocal, but I'm going to take the reciprocal of this original one because that's much easier than taking the reciprocal here and then rationalizing the denominator. Sorry, that should be √2/1, which is just √2. This one is secant theta, so I know it's √2 over -1, which is -√2. And then cotangent theta is x. Oh, sorry, I don't need the formula. I just need -1/1, which is still -1. Okay, so it is possible for cotangent and tangent, or some of the values, to be exactly the same if that's how it works out. Okay, this last one, same idea, but it's slightly different because now it's 0 degrees. Okay, you guys ready? This one's a little weird. Because if it's 0 degrees, that means like I haven't started. This is all it is, and there is no triangle. Well, we are going to pick our lengths. So let's pick the easiest possible number, which is 1. Okay, so 0 degrees here. And then that means this point is 1, 0, right? Because my x goes 1, and then we don't go up or down. If you chose a different number, it would also work, but remember, we're thinking for like ease of access here, or like the easiest number possible. So 1 is my r, because that's what I chose. It's also my x. Do you see how like if I drew a circle here, my radius is 1, right? But that's also my x value. Okay, so now we have sine, which is y over x, r. Sorry about that. And here's where you have to be really careful. Y over r is 0/1, which is just 0. Okay. Cosine is x over r, which is 1/1, which is 1. Tangent is y over x, which is 0/1, still 0. Okay, so far we're doing okay. Remember, anything with a 0 on top divided by anything is 0. So you see how like no matter what numbers I picked, it would be the same, right? If you picked a radius of 5. Now, let's go cosecant. That's 1/0. Okay, this is where you have to be careful. 1/0 is actually undefined. Okay, it's not 0. If you did this on the calculator, it would tell you undefined. Secant theta is 1/1, because it's just the inverse or reciprocal, which is still 1. And then cotangent will be 1/0. That's undefined. Now, how can I make this trickier? Well, if I use, like, say, 270 here, right, then it would be 0, -1, and then you would have different pluses and minuses, and the y's and x's would be switched. So the next page is for you to try. I've given you 5 practice problems. You can, let's see, how can you check your answers? I haven't made answers, but what you can do is get an answer, like sine, cosine, or tangent, and then type that into your graphing calculator. And then what you can also then do is do sine of, quote, parentheses, -30. Make sure you're in degrees, and those 2 decimal values should match. And that's how you can quickly check your answers. Okay? Let me know if you have any questions. That's it for today.